Alright, this is the third and final part of our lesson on solving right triangles, and that means, of course, finding all of the missing sides and any missing angles. Alright, usually you're given three pieces of information, like here we're given two sides and an angle, and you have to find three pieces of information, like two angles and a side. How about number 9? Alright, for problem number 9, we're given two sides. So we're missing one side and both angles. Alright, so if we're going to have to find both angles, what do we use to find angles? Inverse trig functions is what you better have been saying. Alright, so we're going to need inverse trig functions. So just pick an angle to start with. I think I'm going to just pick E. Doesn't really matter, but I'm going to pick E. Alright, so I'm looking at angle E. You know what, let me do it this way. I'm looking at angle E, and I'm looking at the two things that we're given. And I'm trying to decide which trig function this is going to be. But it helps to understand that this 28 is the hypotenuse. So there's that. And this 19 is the adjacent leg. Adjacent leg and hypotenuse. Have you memorized this, or you still have to wait for the cheat sheet? Alright, adjacent leg and hypotenuse, well, that's the cosine function. Alright, so that's why we're going to start off doing cosine of angle E is equal to adjacent over hypotenuse, 19 over 28. So if you want to find the angle, you use the inverse cosine. Okay, and you must show each of these steps, mandatory. And then you can go ahead and write the answer by doing the inverse cosine of 19 over 28 in your calculator. Okay, so that's 47.3 degrees. This is an angle now. Alright, and angles in this case are measured in degrees. Okay, so that is one of the two angles. Alright, so we might as well find the other angle now because it's so easy. Alright, if I want to find angle U, angle U will simply be 90 minus the other acute angle. So 90 minus 47.3. What's 42.7? Degrees. Don't forget your degree symbol or you will be docked. Okay? So we found the two missing angles. Now the only thing we're missing now is the missing side. Okay, but look, you've been knowing how to find a missing side for years. I am not the one who taught you how to do this. It was another earlier teacher. Good old Pythagorean Theorem. Let's see, blue. All right, I'm going to call this UM. But yeah, if you have two sides of a right triangle, you will use the Pythagorean theorem. So a squared plus b squared equals c squared. In this case, becomes um squared plus 19 squared equals 28 squared. So let's see, 19 squared and stuff. 361. All right, 28 squared. 784. So that gives me um squared is equal to 423. All right, and of course now I will take the square root of both sides. Square root of 423. Interesting, 3 radical 47, but you know what, we're doing decimals right now. So 20.6. Okay, and that is it for number 9. All right, we found all 3 missing pieces. All right, in general, it will be 3. In this case, we found 2 angles and a side. All right, I know this video is getting pretty long, but, you know, we just have like 2 more problems left. So suck it up, people, suck it up. All right, so looking at number 10, multiple choice even. How bad can it be? All right, using the diagram to the right, okay. For what value of x does sine A equal cosine A? All right, let's see. So look, they're saying sine A has to equal cosine A, okay? Let's put some numbers on here for fun. Okay, well, not numbers, let's put some variables on here. Okay, so let's say that this is n, and this is p, and this is r, npr, okay? What would be the sine of A? Okay, well, the sine of A, the definition of sine is opposite over hypotenuse. Okay, so in this case, the sine of A opposite over hypotenuse, that would be P over R. Okay, now the cosine of A, of course, the cosine of A is adjacent over hypotenuse. Okay, so that would be n over r. Okay, so under what circumstances, like normally these wouldn't be the same, right? You know, like if this was 3, 4, and 5, for example, then the sine of A would be 4 over 5, and the cosine of A would be 3 over 5. And they're totally different. They are not equal at all. Okay? But there's one special case, the only way that these 2 fractions are going to be equal, you know, considering that the denominators are already equal, r and r. The only way these are going to be equal is if the p and the n are not really 2 different variables, okay? Let me just fix this up. So right now I have n, p, r, like this, but the only way these are the same is if p and n are the same. So like, for example, instead of this being n and p, they have to be the same. So let me call it q and q. They'd have to be the same. So in that case, if these are both the same, so that's why I can call them the same letter, then sine would be opposite over hypotenuse, so that would be q over r. Cosine would be adjacent over hypotenuse, so that would also be q over r. And oh look, they're the same. Okay, so that is the only way, is if they're the same. Now, so that was a fail. So the question is, what angle is it if these 2 are the same? That's the trick. There's only one isosceles right triangle. If these 2 are the same, then this has to be 45 degrees. Okay? Because remember, if you will, this isosceles right triangle, this 45-45 right triangle, occurs by splitting a square in half. So remember, if you it has to be a square because these 2 are the same. You see what I'm saying? So we have a q and a q because it's a square. All four sides are the same. Okay, obviously 90 degrees. Now, if I take that and I split it in half, well, clearly I just took a 90-degree angle and I split it into 45 and 45. Okay, so the only way you're going to get a square, Q and Q, is if this is half of a 90-degree angle, 45 degrees. So I know that was a long-winded explanation, but I'm hoping you understand why it had to be B. Okay, last problem. Solve a right triangle that has a 50-degree angle and a 15-inch hypotenuse. All right, well, draw the picture, for goodness sake. Draw the picture. Okay, so we need some kind of a right triangle. So there's a right triangle for you. And it has a 15-inch hypotenuse, so that means this will be 15 inches. And what else does it say? All right, it has to have a 50-degree angle. Okay, so let's say this is 50 degrees. Okay, so we need to solve a triangle like this. Alrighty then. So I think I'll just put variables and stuff on here. So I'm going to call this side X, and I'm going to call this side over here Y. And here's a new variable for you maybe. I'm going to call this angle theta. Okay, so these are the three things that it would take to solve this triangle. All right, and I'm going to solve them. So I'm going to start with solving for x. If I'm solving for x, then I'm going to highlight that. And of course, I got to use the 50 and the 15. Which trig function involves these three guys? Well, let me remind you that this 15 here is the hypotenuse, just in case that changes your mind. All right, this is the hypotenuse. And the x is the adjacent leg, because look how close it is. So adjacent and hypotenuse, which trig function is that? Well, that's the cosine function, adjacent over hypotenuse. Okay, so I will set up the cosine function. So cosine of 50 is equal to the adjacent leg over the hypotenuse. Is this one where I do the swap, or is this one where I multiply? Yeah, this is one where I'm going to multiply. Okay, that way these cancel out, and I'm left with 15 cosine 50. So that is 9.6. Okay, that's one of the three pieces I need to find. Now I need to find side Y. Okay, so I'm going to switch to that color. So if I'm looking for Y now which trig function am I going to do? Okay, I can forget about that. I'm all done with that. Well, this is still the hypotenuse. So this Y is opposite angle 50. So this is opposite. So I've got opposite and hypotenuse. Which trig function is that? That is the sine function, opposite over hypotenuse. Okay, so I will set up my sine function. So sine of 50 equals opposite over hypotenuse. So y over 15. Now, is this one where I'm going to multiply or do the swap? Yeah, once again, I am going to multiply. All right, I only do the swap thing when the variable is in the denominator. So those cancel out. So that means y is going to equal 15 sine 50. So that is 11.5. Got to round up. Okay, so 11.5 Oh, let's put some units on here, by the way. It's 15 inches, so I got units. So 11.5 inches. That's why. Okay, and the blue one was also inches. All right, last thing we have to find from this triangle, we need to solve for the angle theta. Okay, solve for the angle theta. Well, we don't even need any like trig functions or anything. If we're given one angle, we should be able to find the other angle just by subtracting from 90. Okay, because these both have to add up to 90. So 90 minus 50, that's going to give me the other angle. So theta is equal to 40. And that is it. And that's the end of this lesson. Hope you did not copy off of me. Please make sure that you can do every single problem on this assignment by yourself. Oh yeah, I almost forgot. Degrees. See you on the next video.